Okay guys, so here's a practice problem. We're given a table. This is example A out of the book. And this table relates the approximate wind chills for different actual temperatures when the wind speed is 15 miles per hour. Assume the wind chill is a linear relationship for temperatures between -5 degrees and 35 degrees. So our X is the temperature and our Y is the wind chill. What we're going to want to do here is to find the slope given this table. So I've already put down here the change in Y over the change in X because that's how you find slope. So let's go through, let's start with X because that's pretty simple. Our first X is -5. Our first temperature is -5. To get from -5 to 0, you are going up 5. So it's going to be +5. Okay, now let's just keep doing X because it looks like my X values are just going up by +5. So let's write that out. How many are there? 1, 2, 3, 4, 5, 6, 7, 8 spaces. 4, 5, 6, 7, 8, plus 5, plus 5, plus 5, plus 5, plus 5. Now, here's where it gets tricky that you might forget when you're taking a test or something. Look where I'm putting the value for change in X. I'm putting it on the denominator. But in the table that you're given, it looks like it's on the numerator. It's the top value, right? But we switch it down to be on the denominator when we're finding slope. So let's look at the wind chill. So the first thing is we're going from -0.258 to -19.4. So to find the difference between those two numbers, let's subtract. So go to my calculator, -25.8 minus -19.4. 19.4. Okay? And the answer is -6.4 when we subtract. However, the wind chill is actually getting lower, right? The temperature is getting higher. So from -19.4 is a higher number than -25.8. So I'm going to put a positive because it's going up 6.4. So I know that's a really confusing point right there. When we do the subtraction, we get a negative number. However, it's still getting bigger. The numbers from, let's see, the numbers from here to here are actually getting bigger. -19.4 is a larger number than -25.8. So I had to make that a positive 6.4. So let's keep going. We can type in -19.4 minus, oops, darn it, 0.4 minus -13, and you get -6.4. But it's actually positive 6.4, right? Okay, let's try this. Oh, what do you think? Let's do one more between 19 and 25.4. Way over here, because those are the only other two numbers. And if we get 6.4, we're going to have a pretty good idea that each time it's going to get bigger by 6.4. So 19 minus 25.4. Again, we're subtracting. We get -6.4, but remember, it is getting bigger from 19 to 25.4. It's a bigger number. So that's going to be positive 6.4. So I think each time it's going to be bigger. So can we finish filling out that table? Between -13, if I take -13 and I add 6.4, I I get negative 6.6, so that's going to go directly under 10. Let's see if I can do this. Negative 6.6. Yay! And between there and the next one, I'm going to add 6.4. Just give me negative 0.2. Cool, that's a negative 0.2, looks terrible. And then if I add 6.4, gives me 6.2, which is the next one, yay, and let's finish this. Plus 6.4 is going to be 12.6. So here is going to be 12.6. So we filled out our table, and we know that all of these are going to be 6.4 over 5. So we're going to have an exact slope. So we simply take 6.4, which is the change in the y value, divided by 5, the change in the x value, and our slope is positive 1.28. So our slope, or our n, is 1.28, right? And then, look, the table gives us our y-intercept of negative 19.4. So I can actually finish the equation because our y-intercept, or our b, is negative 19.4. So if we substitute this in, because the problem says it's a linear relationship, y equals our slope 1.28, positive, it's getting bigger, both the x and the y values are getting bigger, x, and then plus our y-intercepts, you can either say plus negative 19.4, or it could be just minus 19.4. That would be our starting value, correct? Okay, so I hope you guys have lots of questions about this. So during class, I can make sure you're understanding what's happening here. And we will have some more examples to do in